Okay, so this is the second number 85. Sorry about the numbering thing. So here we're dealing with the electrons in the atom stuff, okay? A designated electron configuration versus orbital notation. Electron configuration is the writing out, the orbital notation is the arrows. So for our first one here, we've got nitrogen, and I ask for the electron configuration. So we just follow along that periodic table, and we get 1s is full, 2s is full. When you get over to 2p, and you're looking at the periodic table, there's only going to be 3 electrons there, so it's 2p, 3. For chromium, I'm asking you to the orbital notation. When you're dealing with orbital notation, you only need to draw the lines that you actually need for the question. Okay, so for chromium, we've got 1s, which is going to be full. We've got 2s, which is going to be full. 2p, which is going to be full. Remember Hund's rule as you do this, okay? 1 in each orientation before they pair up. After 2p, we've got 3s, which is full. Then we have 3p, also full. Then we've got 4s, which is full. And then we go to 3d. Remember, 3d, even though you're filling it after 4s, you include it on the same line as the other 3s. Okay, you're going to include it with the same energy level. When you get to chromium, okay, you look at section 3d and you count 1, 2, 3, 4 electrons in that section. Again, don't forget Hund's rule. All right, and you're going to end up with 1 on each line. All right. Sorry about that. Okay, so then for part C, we're doing the orbital notation for sulfide ion. Okay, again, remember the word ion means charge. Sulfur has a -2 charge. That -2 is telling me that it's going to gain 2 electrons. Okay, so we get going, and we've got 1s, which is full. 2s, which is full. 2p, also full. 3s. And then sulfur normally, okay, is going to have those 4 electrons. But because it's an ion, it's going to gain 2 more, okay, because of that ion. And that 3p is going to be full. All right, strontium in its excited state. Okay, so remember that when something is in its excited state, that means it's jumping to a higher energy level. So we find strontium on the periodic table. 1s is full. 2s is also going to be full. 2p, full. 3s, full. 3p, full. 4s, full. 3d is full. Again, even though I know these are going to be full, I use Hund's rule anyway, just to keep me in the practice. After 3d, then we hit 4p. And then after 4p, we're at 5s. Okay, strontium normally ends in 5s with 2 electrons. But because we're in that excited state, we're going to remove that last electron, and it's actually going to jump to the next energy level, which would be 6s, and the electron is going to end up there. All right. Then we've got antimony in its excited state. Okay. And it's just asking for the electron configuration. So we can just get going. Following that periodic table, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p, and then it's normally, okay, going to be 5p3, but then the last electron jumps, and so this now becomes 5p2, and the next electron, okay, instead is going to end up in 6s1. Then we're just dealing with barium in its ground state configuration, so nice and long, about as long as I'm going to ask you. Remember, we're not going past element 56, so this is literally as long as I can ask you. I'm going to sort of separate these two because I'm going to need some space for barium because it's a long one. So I'm actually going to separate them like that and go ahead and do barium separately. So barium is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. After 4s2, you hit that 3d10, 4p6, 5s2, 4d10, 5p6, and 6s2.